In this video, we're going to start the KutaSoftware Infinite PreAlgebra free worksheet, Factoring Monomials. Now, our instructions on the first page are to write the prime factorization of each, and it says to do not use exponents. So again, prime factorization is we're simply splitting up the number given into its factors, but only those that are prime. So if we get a factor that isn't prime, we need to split that up into more primes. And because it says not to use exponents, if we get a prime factor 3 times, we'll write it all out as opposed to using to the third. So let's dive into number 1. Now in number 1, we have 25n squared. So n is our variable, and we don't know whether that's prime or not prime. So that's going to remain as a variable, but it says not to use exponents, so n is going to become n times n. But first, let's work on 25. 25, in order to write that as a prime factorization, that's going to be 5 times 5. And remember, our prime numbers are numbers where their only factors are 1 and itself. So that would be 2, which is the only even prime number, 3, 5, 7, 11, 13, 17, and so on. So 2 does not go into 25 and 3 does not go into 25, but 5 does. 25 is 5 times 5. Those are both prime numbers. So 5 times 5, remember we're multiplying by n squared, so times n squared. We have our prime numbers, but we still have this exponent, so we're going to write 5 times 5 times n times n. That's the prime factorization without using exponents of 25n squared. Let's go into number 2. In number 2, we have 18 times xy. Now 18 is an even number, so I know it's divisible by 2. So I'll write that as 2 times 9. 18 is 2 times 9. And we still have this multiplied by x and multiplied by y. Now I'm done with my x and y because there's no other way to split them up. I don't know if they're prime or not. We're just going to leave those as variables. But 9 is not prime, so I have to split 9 up into its prime factors. So that's going to be 2 times 2 doesn't go into 9, but 3 does. 3 times 3 gives us 9, and we'll multiply that by x and y. So you can see I have all prime numbers multiplied together with my variables, so this is the prime factorization of 18 times xy. 2 times 3 times 3 times x times y. Now in number 3, we have 12a. 12 is divisible by 2, so I'll write 12 as 2 times 6, and that's all multiplied by a. Now 2 is a prime number, a is our variable, so we're going to leave that, but 6 is not prime. So we're going to find the prime factors of 6. 2 times 6 is 2 times 3. So I have 2 times 2 times 3 times a. That's my prime factorization of number 3. 2 times 2 times 3 times a. If we were using exponents, this would be 2 squared times 3 times a, because I have 2 2's. But we're not, so we're going to leave it as 2 times 2 times 3 times a. Now in number 4, we have 21 times y squared. 21 is not prime. 2 does not go into 21, but however 3 does. 3 times 7 equals 21, and we're multiplying that by y squared. Now 3 is prime and 7 is prime, but remember we can't have exponents in this problem. So I'm going to write 3 times 7 times, breaking up my y squared, as y times y. So 3 times 7 times y is my solution in number 4. Now in number 5, we have 81. And 81 I know is 9 times 9, so I'm going to rewrite that to make this problem easier. So I have 9 times 9 times a. Now I didn't pull out any prime factors yet, I just simplified down to make finding the prime factors easier. 9 times 9 Neither of those are prime, but a is itself as a variable, so we'll leave that a. Now, 9 can be written as 3 times 3, where both 3 and 3 are prime, and this other 9 can also be written as 3 times 3, so I'll have 3 times 3 times 3 times 3 times a. That's the prime factorization of number 5 without using exponents. If we were, it'd be 3 to the 4th times a, which I think is a little cleaner looking. However, we're going to follow our instructions. In number 6, we have 92 times q. 92 is definitely divisible by 2 because it's an even number. So 2 times what gives me 92? And that's going to be 2 times 46. And that will get multiplied by q. Now, my 2 is fine because it's prime and my q is my variable, but 46 itself is divisible by 2. So that's going to be 2 times 46 is 2 times 23. So if I have 2 times 2 times 23 times q, I have the prime factorization because 2 is prime and so is 23. So 2 times 2 times 23 times q is my solution in number 6. In number 7, I have 36 times x cubed. I know 36 is divisible by 2, but I also know that 36 is 6 times 6. So I'm just going to split it up into factors even though they're not prime. So I'll have 6 times 6 times x cubed. Now I broke this up into 6 times 6 because I know that 6 can be broken up into 2 times 3. So I'll have 2 times 3, which are prime factors, and then this other 6 will be 2 times 3, and I'll multiply that by x cubed. Now I'm going to put my 2's and 3's in order, least to greatest. So I'll have 2 times 2, because I have 2 2's, times 3 because I have 2 3's. Now these were prime, but my variable still has an exponent, and our problem stated no exponents. So I'm going to split x cubed up into x times x times x. So 2 times 2 times 3 times 3 times x times x times x is our prime factorization in number 7. In number 8, I have 24 times h. Now I know 24 is divisible by 2, but I'm going to switch this up a bit and find different factors that I can then split up into the prime factorization. Numbers that divide 24 evenly would be 4 and 6. So 4 times 6 times h is 24h. Now I can just simply find the prime factorization of 4 and the prime factorization of 6. 4 is 2 times 2, and 6 is 2 times 3, and that's all multiplied by h. 2 times 2 times 2 times 3 times h is my solution in number 8. Again, I could have broken this up as 2 times 12 times h, and then broken 12 up as 2 times 6 times h, and then broken the 6 up as 2 times 3 times h. But sometimes it's easier just to find those closer numbers that divide 24 and then break those prime factorizations up. Either way gives you the same solution. Now, in number 9, we have 48 times x squared. 48 is indeed divisible by 2. It's also divisible by 4. And not only that, it's also divisible by 6. If I were to write the factors of 48, I would have 1 and 48. I would have 2 and 24. I would have 3 and 16. I would have 4 and 12. And is there any other numbers in between 4 and 12? Yes, there are. There's 2 more numbers, 6 and 8. So I have the factors 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. So I'm going to use 6 and 8 because those are easier to work with. I could also use 4 and 12, 3 and 16, and 2 and 24. If I used 2 and 24 or 3 and 16, I've already split off one of my prime factors. However, either way of going about this will give you the same result because there's only one way to write a number as its prime factors. There is no other number that will have the same prime factorization which is why this is a very important skill to learn. So 48, I'm going to start by just writing it as 2 factors. Not necessarily the prime factors, but just 2 factors. Now I'm going to break those factors up even smaller. 6 can be written as 2 times 3, and 8 can be written as 2 times 4. And that's all multiplied by x squared. Now I have 2 times 3, which is 6, and those are both prime, times 2, which is prime, but 4 is not prime. 4 can be written as 2 times 2, and then I still have that by x squared. Now I'm going to arrange my numbers in order from least to greatest. So 2 times 2 times 2 times 2, 4 2's, times 3 times, I don't want an exponent for x squared, so I'll write that as x times x. So 2 times 2 times 2 times 2 times 3 times x is the prime factorization of 48x squared. And let's double check. 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 3 gives us 48. Now in number 10, we're dealing with 92xy. But if you remember up in number 6, we already found the prime factorization of 92. But just for practice, let's do it again. 92 is divisible by 2. 2 times what gives me 92? And that's 2 times 46. And I'm multiplying that by x and y. Now 46 is 2 times 23. And all of these are prime, so I just multiply by x and y to get my prime factorization. 2 times 2 times 23 times x times y. Now on to number 11. In number 11, I have 18 times x squared. 18, I know, is 2 times 9. And I'll be multiplying that by x squared. Now, 2 is prime. My x, I still have an exponent, so I'm going to have to deal with that. But 9 can be written as 3 times 3. So I'll have 2 times 3 times 3 times x squared, I'll write as x times x. So now I have my prime factorization because I have all prime numbers multiplied by my variables without exponents. 2 times 3 times 3 times x times x. Now in number 12, I have 50x. 50x is indeed divisible by 2, but I'm actually going to start with larger numbers. I'm going to divide it by 10 at the start. 5 times 10 times x is 50x. 5 is prime, so now I'm just going to deal with 10. And my x is also without exponents. So I'll have 5 times 10 is 2 times 5, and that's all multiplied by x. So now just writing them in order, I'll have 2 times 5 times 5 times x. And when I say writing them in order, I'm just starting with my lower number, working my way up to my greater numbers. So 2 times 5 times x is my solution in number 12. Now onto the second page. In the second page, we're going to write the prime power factorization of each. So now we're going to be using those exponents. So 16 is divisible by 2, but it's also divisible by 4. So I'm first going to start by splitting it up as 4 times 4. So 4 times 4 times y is 16y. Now 4 can be split up into 2 times 2, and so can 4. So I'll write this as 2 times 2 times 2 times 2 times y. Now, in numbers 1 through 12, this would be perfectly fine because we have all primes and a variable. However, we're doing the power factorization, so we're going to write this with exponents because I have 1, 2, 3, 4 2's. 4 2's multiplied together is equivalent to 2 to the 4th. So I have 2 to the 4th times y as my prime factorization of 16y. Now in number 14, I'm looking at number 28. 28, I can divide that by 2 at the start. I can also divide it by 4, so let's start with 4. 4 times 7 gives me 28, and I'll multiply that by y. Now I know that 7 is prime and y is our variable, but 4 I'm going to split up into its prime factors, which are 2 and 2. So 2 times 2 times 7 times y is my prime factorization without exponents, but because I have two 2's, I'm going to write that as 2 squared times 7 times y. 2 squared times 7 times y is my solution in number 14. In number 15, I have 8 times v. 8 is not prime itself, but I can split it up into its prime factors. 2 times 4 is equal to 8. However, 2 and v are fine, but 4 is not prime. I'll write 4 as 2 times 2. So 4 is 2 times 2. I multiply that by 2, and that also gets multiplied by v. Now this is the prime factorization, but not prime power factorization. So 2 times 2 times 2 is 2 to the third times v. And it's 2 to the third because I have 3 2's multiplied together. Now looking at number 16, I have 18xy. 18 I'll split up into 2 times 9. So I have my prime number 2, but 9 is not prime. So I'll still have to split 9 up, but I'll leave x and y as is. Because there was no exponents to even work with, I'll just have x times y. Now 9 is 3 times 3. So I'll have 2 times 3 times 3 times x times y. And to get the prime power factorization, I have all prime numbers and my variables. So I'm going to have 2 times 3 squared times x times y. That's the prime factorization in number 16. In number 17, I have 10y squared. Now, I can have exponents, so I'm going to leave y as y squared. So I'm just going to work with my 10. That's going to be 2 times 5, and that gets multiplied by y squared. Now, because 2 is prime and 5 is prime, and y squared could be written as y times y, but when simplified, that's still y squared. This is my prime factorization in number 17. In number 18, I have 20b squared. So if I start by finding the smallest prime number that goes into 20, that would be 2. So I can have 2 times 10 times, I'm going to leave b squared as is, because I split this up into b times b. Eventually, because I can use powers in the second page, I would eventually put it back as b squared. So 2 is fine and b squared is fine, but my 10 can be written as 2 times 5. So I'll have 2 times 2 times 5 times b squared. 2 times 2 times 5 times b squared. Now, because I have all prime numbers, I can now simplify. Because I have 2 2's, I'll have 2 squared times 5 times b squared. That's the prime factorization in number 18. In number 19, I have 21x squared. Now, 21 cannot be divisible by 2, but it is divisible by 3. That's 3 times 7, and I'll multiply that by x squared. Now, if you notice, 3 is prime, 7 is prime, and then x squared cannot be simplified any further. So 3 times 7 times x squared is my solution in number 19. Now, in number 20, I have 77. And 77 is divisible by 7 and 11. 7 times 11 gives me 77, and then that's multiplied by y. 7 is prime, 11 is prime, and y is itself. So 7 times 11 times y is my solution in number 20. In number 21, I have 84 times AB. There's no other way to simplify down AB, so those will stay as is, but 84, I'll start by dividing that by 2. 2 times 42 times A times B is 84AB. Now 42 is divisible by 2 again, but as opposed to dividing it by 2, I'm just going to split it up by factors bigger than 2, which is 6 and 7. And that's all multiplied by a times b. So now I have my prime number 2, my prime number 7, a and b can stay as is, so I just have to deal with 6, which isn't prime. But 6 is 2 times 3. So I have 2 times 3 times 7 times a times b. Now I have all prime numbers multiplied together with my variables, so prime factorization, but let me group the numbers together that are the same and write them with exponents. So 2 times 2 is 2 squared, and that's multiplied by 3, which is multiplied by 7 times a times b. 2 squared times 3 times 7 times a times b is my solution in number 21. In number 22, I have 78a cubed. So my a cubed is fine as is, so that will stay, but let's deal with this 78 because it isn't prime. 78 is divisible by 2, so I'll start with that. 2 times what gives me 78? Well, if we looked at 78 and divided that by 2, 2 goes into 7 3 times 2 is 6. Bring down that 8, 2 goes into 18 9 times. So 39 is how many times 2 goes into 78. So 2 times 39 times a cubed is 78 times a cubed. 2 is prime, a cubed is fine, but 39 is not prime because 39 I know is divisible by 3 because 3 plus 9 equals 12 and 12 is divisible by 3. So 2 times 39 is 3 times 13, and that gets multiplied by a cubed. 2 is prime, 3 is prime, 13 is prime, and a cubed is fine because eventually using exponents we would simplify that down anyway. So 2 times 3 times 13 times a cubed is my solution in number 22. In number 23, I have 52 times uv. There's no other way to simplify down uv, so that will be as is. Now we just need to rewrite 52. 52 is divisible by 2, so I'll start there. 2 times what gives us 52? That's going to be 2 times 26. Multiply that by u and multiply that by v. Now 26 is not prime. 2 and u and v are fine. 26 is divisible by 2. So rewriting 26, I'll write that as 2 times 13. And that gets multiplied by u and v. Now I have all prime numbers multiplied together with my variables. So grouping the repeated ones, I have 2 2's. So that will be 2 squared, because 2 squared is equal to 2 times 2. I'll multiply that by 13, then u, and then v. 2 squared times 13 times u times v is my prime factorization in number 23. In number 24, I have 66 times y. 66, well, to start, I'll break that up into 6 times 11, and I'll multiply that by y. Now, 11 is prime, and y is my variable, which can't be simplified further, but 6 I can split up into 2 times 3. So 2 times 3 times 11 times y, all of those are prime numbers or variables, none of them are repeated, so 2 times 3 times 11 times y is my solution in number 24. In number 25, I have 82ab. Let's think about 82. 82 is divisible by 2, so I'll have 2 times, what goes into 82 2 times? That would be 41. And I'll multiply that by a and multiply that by b. Now, 2 is prime, 41 is also prime, and a and b are our variables that can't be simplified down any further. So 2 times 41 times a times b is my solution in number 25. And I know that 41 is prime because the only factors of 41 are 1 and 41. No other whole number divides evenly into 41. Now on to number 26, the last problem on this worksheet. And for 26, we have 26x squared. And I know that 26 can be written as 2 times 13, and that will get multiplied by x squared. So here is my prime factorization, my prime power factorization, because I'm leaving exponents within my problem. And with that, we wrap up this worksheet. If you have any questions, please put them in the comments below, and if you're confused on prime factorization, check out my lesson video or a previous worksheet. Now, if you want more ways to support me, become a patron. Check out the Patreon link in the description below, but as always, the best way to support is to like, subscribe, and share. Until next time, happy learning!